Day 40, AP Physics, page 860, number 35. It's back to our parallel plate situation. Electrons go opposite the field. The fields are defined in terms of positive test particles. But bottom line is, a typical situation would be here where if you have 10,000 volts, which is 10,000 joules per coulomb, which might help you get started. Always helps me. The electron will fall through that or travel across that and pick up kinetic energy. Right now it has potential energy of 10,000 joules per coulomb. It says, what is the maximum energy of the photon? Well, it's going to be the energy that the electron gains. You can calculate its potential energy right now, or you can look at delta V equals delta U over Q. The potential energy will lose, transfer to kinetic energy, or also, as a result, can transfer to a photon. It can emit a photon when all that energy is transferred to the photon. But bottom line is we have delta V, 10,000 joules per coulomb, equals delta U over the charge of the electron, 1.6 times 10 to the negative 19th coulombs. So you can get delta U. That will come out in joules as I have it right there. And that would be the answer to part A. The maximum energy that an X-ray photon can gain is that particular energy. Now it says, what is the minimum corresponding wavelength? That'd be like part B. Well, that would be E equals HF. The energy of a photon is Planck's constant times the frequency. So the answer to part A would be this. And you look up Planck's constant in the standard version with joules, and you could calculate F. So now you will have the frequency of that photon. And therefore, that would be the maximum frequency, because that's a complete transfer of all the energy. And it says, what's the minimum corresponding wavelength? Well, we've got to keep going here. Just use V equals lambda F now, because you'll know that frequency. You also know the velocity is 3 times 10 to the 8th, as it always is with a photon when it's in air. So that would give you the minimum corresponding wavelength, because the minimum corresponding wavelength matches up with the maximum frequency. And then it says, do the calculation in electron volts. All right, well, that would be part C. It's going to be 10,000 electron volts, because that's the definition of electron volts. And I don't have the book handy right now, but you can go look that up, example 24.8.